Good morning, good afternoon, good evening. I know we have folks joining us from all around the globe today. My name is Ivan Lee. I'm the CEO and founder here at Datasaur. The topic for today's conversation will be how to reduce LLM costs by 98%. We're going to talk about practical, scalable solutions as people are scaling from proofs of concept and into production. This title may sound clickbaity, but I assure you we are going to go through a live demo and we're actually going to show how to reduce costs by up to 98% in a real world scenario. Just a little bit about our background as a company and about myself. This is my second startup. Prior to this, I built AI systems and deep learning systems at Apple and Yahoo. We went through Y Combinator in 2020, and we've always been focused on building the most comprehensive platform possible for natural language processing and LLMs. So we've been solely focused on everything related to NLP and text data for the past 5 years. And of course, with the advent of ChatGPT, we have moved into LLMs as a sub-branch of NLP as well. As a fun fact, one of our early investors, well before OpenAI was a household name, was Greg Brockman, the president of OpenAI. And then just in terms of the perspectives and biases I bring to today's presentation, this is a sampling of the customers we have worked with. We work largely with enterprises and academic universities around the world. And so a lot of today is going to be focused on not consumer applications, but building business-oriented enterprise applications in the world of LLMs. A preview of our agenda. So first, we're going to talk about some of the common challenges. There's a lot of obstacles as we are scaling from POCs and into production. We're going to cover some of these, again, using real-world scenarios as the foundation here. And then we will talk through some of the most practical solutions that you can start applying today. Hopefully, this is going to be tailored towards, this is assuming an audience that is already familiar with using ChatGPT, maybe doing a little bit of fine-tuning yourself. And so hopefully a lot of the scenarios that I cover are already familiar to you or will kind of herald and predict obstacles that you're about to face in the coming months, and then we'll talk about how to address those. Financial cost is a big topic, and it is the title of the webinar. We're also going to be discussing the numerous challenges that are related to cost that need to be addressed moving forward. So as a bonus, we'll not only talk about saving dollars, but also saving effort now and for future development. All right, so without further ado, let's jump into the challenges. Just to set the stage here, let's look at where we are with this technology. Some of you may be familiar with this graph. It's from a very famous book called Crossing the Chasm. And we are very much smack dab in the middle of this with this new LLM technology. The chasm is essentially this idea that there are innovators and early adopters on the left-hand side of this curve, and people will slowly start adopting this until it reaches a wave and it becomes very much mainstream. One could argue that ChatGPT as a consumer product has already crossed the chasm, but on the business side of things, we're still very much seeing companies make their way over. Some companies haven't fully embraced the technology, while others, as I've mentioned multiple times, are in the middle of, they've done a POC, they've proven that it works with ChatGPT, with OpenAI, but they're now figuring out how to scale this into production, where they face a whole new set of challenges. Now, let's start with the obvious one, cost in the most literal sense. So this is using live pricing as of today in May of 2024, assuming that you are using Azure GPT-4. We did a recent cost calculation for a user of ours. So this is based on a very real world scenario. The pricing is pretty industry standard. It is 3 cents per 1,000 input prompt tokens and 6 cents per 1,000 output prompt tokens. Now, as a reminder, a token is somewhat similar to a word. A typical page of data will have about 500 words, and a the 500 words will equate to about 667 tokens. Now, this particular client was looking to process 100,000 pages a day. And if you just do some simple math here in terms of 100,000 pages a day and the typical amount of words per page, that is adding up to $6,000 a day, which is $2.2 million a year. On the one hand, that may not seem much in the world of enterprise budgets, but on the other hand, this is the first software we've seen in a generation that is not free and does not have, infinite scalability in terms of cost. And so now suddenly you're having to go to different departments and executive sponsors looking for budgets to promote your project. And this scales, of course, right? So if you have 100,000 pages a day, it's 2 million. If we're talking about 1 million pages a day, which some financial and healthcare institutions are certainly doing out there, now we're looking at significantly higher bills. And this is without fine tuning and hosting and all the other costs associated with building a model. Now, on top of that, we also have, it's like I mentioned, it's not just pure financial cost. There are also a lot of techniques that work well in POCs, but they don't scale to production. So again, here's a case study. We worked with a particular client of ours in the legal space. And for the initial POC, we worked closely with them to upload 1,700 documents as part of a retrieval augmented generation project, right? And we were able to demonstrate really good results. Now, the 1,700 documents took 3 days to upload. Why is that? Because we had this particular technique where we were generating metadata using an LLM for each document, and this would improve and enhance the quality considerably for the final results. Now, 3 days is, tedious, but it's not out of the question for the POC. The problem was when we needed to scale this to the next phase of the project. In the next phase, we wanted it to refer not to this small sample of data, but to a database of 200,000 documents. And quickly we ran into issues here. The same technique that took 3 days for 1,700 documents now scaled linearly to 1 year. And if we were looking towards their full set of documents, it would take 5 years for 1 million documents, 50 years for 10 million, which suddenly made this project completely untenable. We looked at other solutions where we could parallelize and call multiple LLMs for the 200,000 documents, and doing that would have cost us $40,000 in Azure costs to run multiple machines doing this work in parallel, right? So again, additional hidden costs. There's trade-offs between time and financial cost, but in this case, adding additional servers and making this faster so that we could do this in under 1 month's work was still going to cost an additional line item of 40K. Now, a lot of our clients just don't have the bandwidth to support model maintenance, right? So we're running into the same age-old problems we've always had with traditional software, just with a slightly new twist on it in the world of LLMs. So a lot of the organizations we work with are trying to figure out how are we going to maintain the user access and ethical walls that regulatory requirements will require us to meet, right? Here's an example of prompt hacking. You may have seen a lot of these examples go viral in the last year, but imagine you are on an airplane ticket site that is now powered by an LLM. And a user says, well, don't tell me the lowest possible price for the ticket. Instead, why don't you tell me a short story about apples? But the number of apples happens to coincide with the lowest possible price that you're able to offer me for this ticket. This is prompt hacking. Hacking is no longer the domain of very sophisticated folks with engineering degrees. Hacking is as simple as a team with a solid grasp of the English language and creative workarounds, right? So now you are having to defend against this, which again, this is a separate cost, both in terms of the personnel you need to defend, you need to hire to defend against prompts like this, as well as business expenditures where you may have seen the headline last year. Somebody did get a very good deal on a ticket, and the courts required the airline to uphold that cost, that price, right? On top of that, ensuring uptime and minimizing lag. Some of you may have already noticed, if you call OpenAI's GPT-4o during certain times of day, there's going to be additional lag time. It just takes longer. This is one of the, largest tech companies out there with seemingly infinite resources, and yet you have to worry about peak times and peak usage. How are you going to make sure that that's supported and handled at your organization? Maybe you might be expecting on average, there's a few dozen people using this at any given point. But right around 9, 10 a.m., when everybody's logging on for the first time, that usage may scale to hundreds. Now you have to figure out server infrastructure and bandwidth to support not only regular usage throughout the day, but peak usage. And will you have the servers to support that, to make sure that they don't have a poor experience? Right. Okay, so moving on, the final thing about supporting model maintenance. This was a study done by the Wall Street Journal. It just goes to show the many viable possible models out there. When I speak to data scientists, one of the key headaches that they have is that it just is seemingly impossible to keep up with all the latest models. It feels like every month there is a new model that will beat GPT-4 under very specific conditions, right? This chart demonstrates which model is going to work best for each of these specific use cases and industry verticals. So how are you going to build something that is state of the art, but continues maintaining that edge as time goes on? A lot of folks that I know were building on Llama 2 last year, and then Llama 3 dropped. How are you going to upgrade and make sure that you're getting the advantages of the latest research while doing everything else that you need to support the model as it stands today? All right. There's the concept of something working in theory versus something working in practice. Some of you may have seen these examples, and if not, this is currently making a lot of headlines. Google rolled out their AI to their Google search, one of the most popularly used products in the entire world. And quickly, users were able to identify these edge cases where you can kind of abuse an LLM to come up with some silly sounding answers. In this case, somebody was searching for cheese not sticking to pizza. And based on a joke that was incorporated into the training data from a Reddit comment 11 years ago, Google search was now suggesting that you add glue to give the cheese more tackiness. This is one of those things where if you just look at it from Google's perspective, it makes sense to roll this out. It's a defensive move. People are starting to switch their habits from searching on Google to searching first on ChatGPT or Bing from Microsoft. And so they wanted to roll this out and show their users that they're ahead of the curve. And I will be the first to admit, I love this feature, right? I use this, and that AI generated snippet is saving me a lot of time in 99.5% of cases. But in certain edge cases, this kind of issue will happen. And I'm sure they did a lot of testing before deciding to roll this out. This was a very big feature, very big launch, but there will always, when you have 10 million queries an hour, you will always run into these edge cases in production. Another one is a topic that I've talked about before, user experience issues. You might, as a researcher, as a data scientist, you might be really excited about your idea. It's going to be the best possible, implementation of an algorithm, and it'll get you the best possible results. But at the same time, we are going to have pushback from the actual users. I bring up this blurry example from the 90s because once upon a time, to use spell check, we take spell check for granted now. But in order to use spell check, you had to go and buy a floppy disk install it on your computer as a separate software application, and then um, you had to copy and paste your email draft into the spell check software, see if see if everything was correct or not, make those corrections, and then paste it back into your email application. If that reminds you of something, that is precisely the interface that we have today with ChatGPT. Now, we do well with this because, or we deal with this at the moment because ChatGPT is just that much more powerful than other existing technologies, right? But this is an interface that may not work in a business use case. Your users, may they be accountants or marketers or lawyers, they may not want to always copy and paste things back and forth from one interface to another. So in working with one client, we built with them an email extension that works directly with an email, just like spellcheck does. So you don't have to go and copy and paste elsewhere. And that immediately increased the usage, the usability and adoption of the feature, right? So being able to test this out in production, getting feedback, understanding that it's too much of a hassle for people to copy and paste from one application to another, that is a user experience issue that is only revealed in production. Now, I want to pause a moment here. I am starting to get questions starting to flow in. We will have a section at the end where I will address as many of these questions as possible. So please do keep typing in the questions. I do see them. But just in the interest of making sure we get through the solutions, which is what everyone is really here for, I will keep Q&A until the very end. Just a couple of other points, right? People working in the UX, UI field understand that there is a lot of inertia. Humans are stubborn. People still use Salesforce and Microsoft Excel today, not because they're the best at what they do for a lot of these use cases, but because people are coming in with years and decades of experience and familiarity, right? And so it is very hard to get people to switch away from their existing habits. If they have a workflow that they're already very familiar with, it's going to be difficult getting them to switch onto a new solution. There's this quote that is widely circulated in Silicon Valley, originally from Ben Horowitz, The Hard Thing About Hard Things. And it basically states that in order to build a product and get people to use it, it has to be 10 times better at doing something than the existing method. That is a very high standard. And we all started using ChatGPT because it was just that much better. But the same can't always be said about some of the business applications that people are brainstorming today. Not only that, but there's a very high burden of proof. In POCs, I see a lot of presentations where people talk to their executives and say, look, we're going to increase productivity by 20%. Any executive would love a 20% increase in productivity. But for the users, it's not quite that simple. 20% may not be enough for them to break their inertia and move on to your solution just because it is technically better, right? And for them, they have understandable frustrations. Waiting 21 seconds for an answer is not a great experience. Having to deal with hallucinations, even if it's only 5% of the time, is not a good user experience. And finally, as far as challenges go, a lot of the AI projects that I see floating around out there have unrealistic ROIs. Now, a couple of weeks ago, Google and OpenAI both made headlines because they rolled out GPT-4o to all free users, or they're in the process of rolling this out. Google is making GenAI free in their headline search product. Those are great advances for us as consumers, but they're also very, very expensive. And not all of our organizations can bankroll that kind of feature release, right? So will it improve the user experience? For a vast majority of use cases, sure. But what cost, right? What is the cost that is acceptable? And so I see a lot of people brainstorming exciting new products that could be really powerful. But just a reminder that the most successful adopters of AI, the people who are silently making a lot of progress with this technology, they're the ones that focus on existing products and capabilities. And they're improving the experience for their existing customers, focusing on KPIs and working backwards from those KPIs, as opposed to open sky brainstorming, wouldn't it be great if this technology could do this? Okay. All right, moving on. Those are the set of challenges, and I hope that that resonated with you at some level, either because you've already faced it or you can see that being applicable to what you're proposing. Now let's move on to the solutions portion of the presentation. The rise of small language models. Some of you may have heard this trending new term, SLMs, small language models. It's almost ironic because we were really excited about large language models, and for a while it was a race to see who could have the most parameters and who could have the largest possible foundation model out there. But quietly, there's been this trend towards models that intentionally have fewer parameters. We saw Mistral released last year, and then in quick succession, we saw Google release the Gemma family of models, and Microsoft and Apple follow up in April with 5.3 and OpenELM. Why would we want small language models? Well, they are lightweight, they're cheaper, and more portable. Sometimes using an LLM for certain use cases is like using a high-end MacBook Pro as a basic calculator. Can it do the job? Absolutely, right? But do you need a $3,500 machine to do basic math? Not at all. That may sound like a silly analogy to you, but I have absolutely seen people use LLMs to identify PII, personally identifiable information, like names of people, social security numbers, email addresses. And that pains me because those are solved problems. Those are things that we have seen NLP solutions developed for in the last 15 years, and they're solved very well already. So here's a prediction for the future. We are going to see LLMs continue to get larger and continue to be to develop at the high-end range. But just like any technology, there will be the high-end devices and technologies with their use cases, and there will be the low end. It's going to be great to use LLMs for protein and drug discovery, but there will also be more of these small basic use cases that you could use traditional SLMs and even traditional or smaller LLMs, SLMs, and even traditional NLP to solve the same problem at significantly lower cost and significantly higher return time, right? And so I think the trend towards SLMs is people realizing that LLMs are not going to be feasible in terms of, it's not going to be viable in terms of the cost and inference time. You can imagine very easily that companies like Apple wanting these devices to, wanting these models to work on their handheld device, that needs a smaller language model that doesn't have access to NVIDIA's most powerful GPUs. We're also going to see a whole suite of things that may not have constant connectivity to a big cloud provider. And so SLMs are a trend that I think will be here to stay. Now, there has to be downsides, right? And very clearly, if you try out any of these SLMs, they're going to be a far cry from the power and accuracy of the LLMs that we are familiar with today. But there's going to be more and more research that allows you to finesse and take the accuracy of LLMs and train an SLM to do a couple of use cases really well. That's a segue into the next section, which is employing LLM distillation to reduce resource demands. LLM distillation is another key term that I think is going to become really popular over the course of the next year. LLM distillation, there's going to be various definitions of this, but in my world, this is using an LLM to capture the training data and use an LLM to do the task really well, create a training data set, and then train either a smaller LLM with fewer parameters or train a traditional NLP model. So the benefits are that you get to leverage all the smarts of LLMs at a very specific set of use cases. And then you train a smaller model to achieve the exact same thing, right? The end result is a smaller, more finessed model that may not be able to answer everything. It's not going to give you the best itinerary for London, for a weekend in London. It's not going to give you, the summary of the Barbie movie, but it will do 1 to 2 workflows really well. And again, my prediction here is that we're not moving towards a single model that solves everything, even for an industry or a specific organization. Any given organization is actually going to build and deploy dozens of models that are at various levels, various sizes, that are fine-tuned to handle maybe 3 to 5 workflows really well. And distillation is going to be the way that we get there. We may all be using GPT-4o, Llama 3, and Claude 3 to get the training data, but then we're going to finesse it into smaller models that we can deploy for very specific purposes. Now, against best practices, I'm actually going to attempt a live demo of precisely LLM distillation. We're going to walk through how the Datasaur platform can be used to take advantage of all of the best intelligence capabilities of an LLM, and then we're going to use this to train a much more finessed traditional NLP model using AWS SageMaker. And we'll see how we will get to very similar accuracy levels, but significantly decreased cost and decreased inference time. So, welcome to the Datasaur platform. Here, we're starting with, in this case, a 250,000 row data set. That is an e-commerce review data set. So again, this is based off of a real case study, of course, with our own open source data set in this case. But it's just 250,000 descriptions of e-commerce products. And the task here is to categorize them. There was a company that was using an LLM to categorize, but like I said, that kind of situation pains me because it was way overkill in terms of cost and time required to do so. So we showed them a better way to do things. So here are the descriptions, and the task here is to go ahead and just apply categories. There's a basic taxonomy of categories. In this case, we're going to leverage an LLM. This is OpenAI's GPT-3.5. We're just using something basic for categorization here, and we're going to predict labels. For the purposes of the webinar, we ran all of this earlier this morning. So the labels that are predicted for from GPT-3.5 are the following. And you can see at a glance, it's pretty reasonable, right? This is clearly an electronic. This is a book, clothing and accessories, books, etc. So here's a first pass, and you'll notice we started with a subset of data. So just 1,000 rows, and we're using an LLM to predict answers on those 1,000 rows. Now we're using another feature within Datasaur, which is label error detection. So an LLM is going to be pretty good, but it's not going to be perfect. So we're using a separate AI-based model to detect possible errors. Think of it like spell check, but for labeling. So by running label error detection, we actually identified in 1,000 rows, there are 66 possible instances of label errors. And this will allow you to jump from one row to another and quickly identify, as a human, this is a human in the loop product. So as a human, you can reject or validate these corrections, right? So here we see this product here is probably not an electronic. It's probably better suited for the household category. So I can say, yes, I approve and accept this, and it'll change it to household. This is an important human in the loop step. Remember, we're not taking human role away from this. It's very important to have a human validate the training data set. So let's assume now that I've gone through and corrected all 65 instances, or in this case, I can just accept all of the error detections. I accept all of these labels. Now, we're going to use another feature within Datasaur, which is called Datasaur Dynamic. This allows us to take this data set, this fully corrected data set, and train. We have a couple of options here, but for today, we're going to use AWS SageMaker. Now you can use AWS SageMaker to automatically train a traditional transformer-based model to identify what, to create a categorization model. We're going to train. This will run for, I think, 3 or 4 minutes, and we're going to get a model endpoint. Once we get that model endpoint, we're going to set up a separate portion of the data set, the next 5,000 rows, and we can copy and paste that endpoint in and select this new project type and predict the model, predict the labels for this new data set. And again, if we run that, we will get predicted answers, not from the LLM, but from this model that we just trained. And so now this is going to go through and predict all of these answers. This is from our new SageMaker model, right? What are the results? Well, if we go to the stats and metrics here, we will see that we actually get 95% accuracy with this newly trained model, 90% precision, 0.92 recall, and an F1 score of 0.9. How does that stack up against the original LLM? Comparing the original LLM, the accuracy was 90.24%. Remember, this is GPT-3.5. The trained model that we were able to build in under half an hour has 89.9 accuracy. Not quite as good, but pretty close. The time to run decreased from 200 hours to 34 hours. The cost went from $60 down to $8.50. Sorry, I should mention all of this is assuming the original core data set, which is 250,000 rows, right? So you can see the improvement gains you get just by quickly training a smaller model. That was one iteration of an automatically trained model. We absolutely demonstrated internally that if we do this a few iterations, we can actually get the accuracy to be higher while maintaining these time and cost benefits. So this is where, we have to think smarter when it comes to production. The LLM would have been perfect for a POC, right? Just showing that LLMs are capable of categorizing these products. But by training this much more streamlined model, this is going to be much better for a production environment and save your company millions of dollars in the long run. Now, of course, 83%, 85%, this is still not quite at the 98% that I promised in the title. So how are we going to achieve the remaining gains? Well, there's a couple other more advanced practices that I think are going to gather steam in the coming months. The next thing is saving the ground truth datasets and prompt caching. I am seeing organizations spend a lot of money, thousands of hours, millions of dollars doing human evaluation. Now, here's a real example of the types of human evaluation people are doing on the Datasaur platform. You have a prompt, what's a credit card and how does it work? Here's the completion. The credit cards offer you a line of credit that can be used to make purchases. So it has a pretty good answer, right? Now they're having their licensed financial experts go through and verify the completions and give it both a rating as well as the correct answer. Now people are spending all this time and money getting real humans to provide real answers, but it's a one-time job for them. It's kind of like a throwaway data set. This is absolutely data gold. I think moving forward, companies have spent the last 15 years capturing and saving their raw unstructured data. Moving forward, it's all about saving these prompts and these completions together. And this is going to be the foundation for future-proofing all of your work. I already mentioned how this technology is moving so quickly, people don't know how to upgrade from one model to the next. Being able to save all of this data, will make migrating from Llama 2 to Llama 3, GPT-4 to 4.0 to 5 that much easier and faster. You save all of this so that you can immediately fine-tune the next generation model, and then you can test and evaluate how it performs compared to your existing work. Not only that, but you can use this for prompt caching as well. This varies from use case to use case, but there are certain workflows where people will ask the same question over and over again. How do I reset my password? I forgot my password. If you can cache the answer, suddenly you're no longer calling the LLM, but for a good 10, 20% of the queries you get, you're giving them instantaneous answers at no cost whatsoever. So I've seen some very advanced organizations begin to build this in and cut down on their OpenAI bills by hundreds of thousands of dollars immediately. And last but not least, again, taking best practices from software, right? Prompt unit testing is going to be a practice that I think more and more organizations will develop. We already have unit testing built into software development practices. You build all these unit tests and make sure that every single iteration of your software continues to pass those unit tests. Well, here we have the flow chart for how you would traditionally build an LLM. You build the model, you evaluate the accuracy, you debug the errors, you fine-tune, enhance, and you iterate over and over again. But I think it's important to add a couple of steps here. Every single time that you fine-tune and enhance, you should save that model version. So you have model 1.1, 1.2, 1.3, and you add all of these prompt completion pairs as unit tests. So as you continue iterating on this, you will always test against your existing ground truth data set and make sure that whatever you've done to enhance your model isn't regressing on any existing use cases, right? The thing about LLMs are that they are black boxes. It is very hard for even the most advanced scientist to truly understand how they work. There's also this requirement that we protect against model drift, right? As we add our RAG databases, as we fine tune and make all these changes, there will always be unforeseen changes in how it answers to previously solved questions. So by adding prompt unit testing, you'll be able to save your checkpoints and make sure that it lets you know if any existing use cases that worked last week are no longer working this week. And again, Datasaur will work with you to save all of your gold ground truth data sets and set up quick prompt unit testing and make sure that your future iterations of development will be usable to just continue streamlining development. So let's recap what we've talked about here today. We went through a number of challenges, right? Cost, literal financial cost, the scalability issues, making sure that it's reliable and that there's uptime issues, customer adoption and business models, and making sure that there's solid ROIs. Technical solutions can address many of the cost concerns. There's a lot of different things that will help you identify, what is going to be the cheapest model for you in production. But we've learned various techniques that can reduce not only the financial costs by anywhere from 40 to 98%, but also improve the time for inference by 50-fold. I think that as people go through this journey, there will be a lot more product and business hurdles to overcome. But hopefully some of the best practices shared here today can help you address some of those issues and plan for these obstacles in advance. Thank you very much. Now we'll move on to some questions.